part two of this video, I noticed that there are some errors here. Now, if you check this 10, which is the length of the pipe, was not used here. So now let's recalculate. Now introduce that 10 here. This 10 here, when you multiply both sides by this value, which is this, multiplied by this. If you multiply both sides by this value, then multiplying this side by this same value, it will cancel out. So that means we are going to make use of this 10 here. So now let's recalculate our pressure D. Now to recalculate the pressure D, we say 417.7 square plus 0.6 times 540 times 0.88 times 10 times bracket open 880 times 10 raised to power 6 times 14.7 divided by 38.77 divided by 20.206 divided by 520 divided by 17.25 raised to power 2.5 bracket close raised to power 2 equal to this. So now let's find the square root of the answer. So we have this now is equal to, let me erase this. Okay, it's like we can erase it. Let me just cancel. Now the answer for PD is 433.06 pxia, which is the same thing as, so if we subtract 14.7 from this, we have 418.35 psig. So this is the absolute pressure, this is the gauge pressure. So now let's now go back to this. So that means there will be an error here. That means the D value here should change. This value here we're going to be using 433.06 square. So that's what we're going to use. So now let's calculate. You use this expression now to calculate our pressure at C. So we have 433.06 square plus 0.6 times 540 times 20 times 0.88 times bracket open 40 times 10 raised to the power 6 times 14.7 divided by 38.77 divided by 19.395 divided by 520 divided by 17.25 raised to power 2.5. Bracket close, raised to power 2 equal to this. So now the square root of this will now be, so that means our PC will now be 442.7 pxia. So these are PC. Now we need to calculate the PB, that is the pressure at B. Let's look at the drawing here. Now we have at B you have the P, the BC. So the length of BC is 45 miles from this diagram, and the flow rate is 90 million scoop per day. 90 million cubic feet per day. 90 million cubic feet per day. So now we have gotten the pressure at C. We are looking for the pressure at B. So now let's go back to let's now represent that diagram here. Now you have B, you have C. Now we have gotten PC to be equal to what? 442.7 pxia. Now we are looking for PB, which is unknown. Now we know the length of this line to be 45 miles. Now we know the flow rate to be 90 million standard cubic feet per day. Now we're asked to calculate the PB. So to calculate the PB, we also need to know the Reynolds number. So we need to calculate the Reynolds number of this particular region. So now the Reynolds number formula is 0.0004778 times bracket open base pressure divided by base temperature bracket close times gas gravity times the flow rate, the volume flow rate divided by the viscosity divided by D. Now we have 0.0004778 times the base pressure is 14.7 divided by the base temperature is 520 times gas gravity 0.6. The flow rate here now is 90 times 10 raised to the power 6 divided by the viscosity of the the internal diameter of the pipe is 17.25. Now divide by the viscosity. Now let's look for what is the viscosity. The viscosity is 7.5 times 10 raised to the power minus 6. 7.5 times 10 raised to the power minus 6. Now let's use our calculator to calculate this. Now we are going to have 0.004778 times 14.7 divided by 520 times 0.6 times 90 exponential 6 divided by 17.25 divided by 7.5 exponential minus 6. Sorry, 10 raised to the power minus 6 equal to. Now what we have here is 5,637,720. So the real number is this. Now let me write it down so that I won't go back to it again. Now let's calculate the transmission factor of this system. So now let's use the formula for transmission factor, which is F is equal to minus 4 log to base 10 bracket open E divided by 3.7 divided by D plus 1.425 F divided by Reynolds number. Now let's assume our F is equal to, let's assume our F is equal to 20, and then now let's calculate for F. So now we have minus 4 log to base 10. Now what is our E? The E is 200 times 10 raised to the power minus 6. Then so that is that. So let's go back. So we're putting our E to be 200 times 10 raised to the power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times the assumed value is 20 divided by the Reynolds number, which is 5,687,720. Now let's calculate the F. Now if this F we calculate is far from the assumed value of F, we now make the calculated value of F the assumed value and use it to recalculate till the difference is infinitesimal. So now that is what we're doing now. Now let's calculate the F there now. So we have minus 4 times log 200 times 10 raised to the power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times 20 divided by 5,687,720 bracket close equal to, so what we have here now is 20 is 20.357. The difference between this and this is so much. We have 0.357 as a difference, so we can now assume this as a value of f to recalculate. So now let's calculate f, assuming f is equal to this. So now f will now be equal to minus 4 log to base 10 bracket open 200 times 10 raised to minus 6 divided by 3.7 times 17.25 plus 1.425 times 20 divided by 5,687,720. So this will be equal to what? Now let's recalculate. Now it's okay. Now this will not be 20. This will now be 20.357. Sorry, 20.3. Let me just erase this. So this is 20.357. 7720. So let's calculate the value of our f now. Now you have minus 4 times log base 10 bracket open 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.45425 times 20.357 divided by 5,687,720 bracket close equal to, so we now have 20.338. So now let's recalculate. We also know the actual value. Now we're going to make use of this as our assumed value. So let's calculate the f again. The f will now be minus 4 log 10 bracket open 200 times 10 raised to minus 6 divided by 3.7 times 17.25 plus 1.425 times now 20.338 divided by 5,687,720. So what will be the f now? Let's now recalculate again. Now we have minus 4 log to base 10 bracket open 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times 20.338 divided by 5,687,720. 20 bracket close. So we have the final answer, which is equal to 20.33 what 339. So this is our final f value that we're going to use, So now we have f to be equal to 20.339. Now let's calculate the pressure at B. So to calculate the pressure at B, we now use a general flow equation, which is the volume flow rate equal to 38.77 times the transmission factor of F, bracket open, times the base temperature divided by the base pressure, times the pressure at B square minus the pressure at C square divided by G time divided by G, that is the gas gravity, divided by the gas temperature, also divided by the length of the pipe segment, divided by the compressibility factor, bracket close, all raised to power 0.5 times D raised to power 2.5. So to calculate our the pressure at B, we now need to rearrange this formula to make pressure at B the subject of the formula. So now to do that, we use 38.7 times F with this bracket open, the base temperature divided by the base pressure times the internal diameter raised to power 2.5. We divide both sides by this whole expression, this one, and leave this one. So we are dividing both sides with this and this. So if we divide both sides by that, we are going to have on the left hand side Q times PB divided by 38.77 F divided by base temperature divided by B raised to power 2.5. Now this will now be equal to P subscript B raised to power 2 minus P subscript C raised to power 2, all divided by G TFL divided by Z, brackets open and close, all raised to power 0.5. So this is what you have. So squaring both sides, we now have P subscript B square minus P subscript C square divided by G TFLG is equal to Q times PB divided by P subscript G divided by 38.77 F divided by T subscript B divided by D raised to power 2.5 all squared. So that means PB square is equal to P subscript C square plus G times TF times L times Z times Q times PB all divided by 38.77F divided by TB divided by D raised to power 2.5 all squared. So we have our PC to be 442.7 442.7 square plus 0.6 as the gas gravity times 540 as the gas temperature times the length of the pipe is 45 miles times the gas gravity 0.88 times bracket open. The flow rate is 90 times 10 raised to power 6 times 14.7 divided by 38.77 times 8 divided by 38 divided by 20.339 divided by 520 divided by 17.25 raised to power 2.5 all squared. So now let's make use of our calculator to calculate this. Now we have 442.7 raised to power 2 plus 0.6 times 540 times 45 times 0.88 times bracket open 90 times 10 raised to power 6 times 14.7 divided by 38.77 divided by 20.339 divided by 520 divided by 17.25 bracket close raised to power 2 equal to now the square root of this. So we have 442.7 square plus 0.6 times 540 times 45 times 0.88 times bracket open 90 times 10 raised to power 6 times 14.7 divided by 38.77 divided by 20.339 divided by 520 divided by 17.25 raised to power 2.5 bracket close, bracket close, raised to power 2 equal to this, then the square root of this is no this because the result is not what I'm expecting. Let me just say, okay, 90 times 10 raised to power 6 times 14.7 divided by 38.77 divided by 20.339 divided by 520 divided by 17.25 raised to power 2.5. Let me see. Gives me 2. Then if I square this, gives me what? 6 point something. Now, if I now multiply 0.6 times 540 times 45 times 0.88 to that value, I have this plus what? 442.7 square equal to this. Then let's now see the square root of this value is what? So what it will give us is now 532 point what? For PSIA. So this is the pressure at B. This is the pressure at what? B. Now we've gotten the pressure at B, we need to get the pressure at what? A. So to get the pressure at A, we go back. So now at A, look at the flow rate is 150. The flow rate is 150 million standard cubic feet per day, and the length from A to B is 25 miles. So, and we have gotten the PB to be what? 532.4 PSIA. Now we are looking for PA is unknown. So now we need to calculate now. So now what we're going to do now is, let's go back. Now we have, let's draw the diagram. We have, this is point A, this is our point B. Now we have the length to be 25 miles. We have the flow rate to be 150 million standard cubic feet per day. Now we have the pressure of B to be equal to what? 532.4 PSIA. Now we are looking for the P at A, the pressure at A. Now, for us to get the pressure at A, we need to know the Reynolds number. So the Reynolds number is 0.0004778 times the base pressure divided by the base temperature times the gas gravity times the flow rate divided by the viscosity of the gas divided by the internal diameter. So let's calculate our Reynolds number. We have 0.00047778 times 14.7 divided by 520 times gas gravity 0.6 times the flow rate is 550. 550 times 10 raised to power 6 divided by 7.5 times 10 raised to power minus 6 as the viscosity divided by 17.25. So we now have our Reynolds number. We'll now make use of our calculator now to calculate this. So 0.00047778 times bracket open 14.7 divided by 520 bracket close times bracket open 0.6 times 150 times 10 raised to power 6 divided by 7.5 times 10 raised to power minus 6 divided by 17.25 equal to, this is equal to 9,396,201. So this is our Reynolds number. We now need to calculate the flow rate. Now, assuming the flow rate, assuming the transmission factor is F equal to 20. Now let's calculate F and compare it with this assumed value. So now we have F to be equal to minus 4 log to base 10 bracket open E, which is 200 times 10 raised to power minus 6 divided by 3.7 divided by D, which is 17.25 plus 1.425 times the assumed value of F divided by the Reynolds number, which is 9396201 bracket close. So this will be equal to what? So we have minus 4 log base 10 bracket open 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times 20 divided by 9,396,201 bracket close equal to now we have 20.840. So Now that is our f. Now we're going to assume, since this value is far from this, we're going to assume is 20.840. Now assuming that value, assume f to be equal to 20.840. Now we have f to be equal to minus 4 log to base 10 bracket open 200 times 10 raised to power minus 6 divide by 3.7 divided by 17.25 plus 1.425 times 20.840 divided by 9,396,201 bracket close. So what? Now let's use our calculator to calculate this to know what should be the answer now. So we have minus 4 log base 10. We have 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times 20.84 divided by 9,396,201 bracket close equal to, now we have 20.804. So we have 20.804. So let's assume the value of f, that is the transmission factor, to be 20.804. So now let's calculate our f. Our f will now be minus 4 log to base 10 brackets open 200 times 10 raised to power minus 6 divided by 3.7 times 17.25 plus 1.425 times 20.804 divided by 9,396,21. So this should be equal to what? So now let's recalculate again. Minus 4 log, now minus 4 times log bracket open 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.425 plus 1. Now let me recalculate. There's an error here. Minus 4 times log 200 times 10 raised to power minus 6 divided by 3.7 divided by 17.25 plus 1.425 times 20.804 divided by 9,396,201 bracket close equal to 20. So the answer is 20.806. So 20.806 should be our final answer, because the error, which the difference between this and this is very minimal. So we're going to use this value here. Now, let me write the formula for the transmission factor so we can follow up with what we have calculated so far. So minus 4 log base 10 bracket open E divided by 3.7 divided by D. The plus E is the roughness, the pipe roughness. So plus 1.425 F divided by Reynolds number. So this is it. So we can now compare it to what we have done so far. So let's now use this to calculate the pressure at A. So the pressure at A, now using the flow rate to be equal to 38.77 F times T base temperature divided by the base pressure times bracket open pressure at A square minus pressure at B square divided by G divided by gas gravity divided by the gas temperature divided by the length divided by the compressibility factor, all raised to power 0.5 times D raised to power 2.5. Now let's make P the subject of formula. P subscript A, and the pressure at A is subject of formula. So P at A square will now be P at B square plus Q times PB divided by 38.77 F divided by TB divided by D raised to power 2.5 all squared times G TF L Z. So that means our P at A square will be equal to P at B, which is 532.4, 532.4 square plus bracket open. The flow rate is what? 150 times 10 raised to power 6 times 14.7 divided by 38.77 times the transmission factor, which is 20.806 divided by 520 divided by 17.25 raised to power 2.5 all squared times 0.6 times 540 times the length is 25 miles times 25 miles times 0.88. So that means P at A will now be equal to what? Now let's make use of a calculator. Let's make use of a calculator. We have 532.4 square plus bracket open 150 times 10 raised to power 6 times 14.7 divided by That's 8.77 divided by 20.806 divided by 520 divided by 17.25. So this equal 2.5. 2.5. So all raised to 14 all raised to 14 times 0.6 times 540 times 25 times 0.88. So it comes to this. So now when I say the square root of this will now be what? Will now be 647.2 pxia. So the pressure at A is equal to 647.2 pxia. So this is the final answer. Thank you for watching till the end. Have a nice day. Also do well to subscribe to my channel. So when next time I make new video, you'll be the first to watch. Thank you and God bless.